is 9.4, mean absolute deviation. So the mean absolute deviation of a data set is the average of the absolute values of the differences between that element and the mean of the data. So what that means in a nutshell is you're trying to figure out how far on average the data set is from the mean. So if we're looking at this next section, it says each line plot has 9 elements and a mean of 5. Of the 3, which line's plot data has the least variation from the mean and which one has the most variation from the mean? So this is a touching back on what we did in 9.3. So this one is the least because they're all very close to 5. And the one that is the most varied is this one, because it's a variety of points. The other one is bimodal. We have these 2 stacks. It's not very varied. It's 2 values. Okay, so by looking at the MAD, we can figure out exactly how much the numbers in the line plot differ from the mean. So we're going to look at this example. The first thing you have to do is get all of these populations from the cities into your table. The next thing it wants us to do is to find the mean of the population. So if you add all of these up and divide by the 10 cities there are, on average, there are 2.54 million people. So what this was asking us to do at this point is to find the means of the absolute first we have to go back to our table. So the deviation from the mean means we're going to take each of these x values written in black and we're going to subtract out the mean. So typically when you see the mean at this point in math, it's going to be that x with a line over it. So for each of these, we're going to take those x values and we're going to subtract our 2.54 because that's your mean. So when you do that, these are the results you'll get. So again, each of these numbers came from taking those x values written in black and subtracting 2.54, your mean. So this next section says the absolute value of the deviations. Remember, absolute value tells you a number's distance to 0. Distance is never negative. So when we do the absolute value, all we're doing is rewriting it as a positive number. So that negative 1.64 will become a positive 1.64. The negative 1.24 will become a positive 1.24, and so on. So each of those numbers written in red is the distance each x value, again written in black, is from the mean of the data set. Now to find the mean absolute deviation, you find the mean of those numbers written in red. So again, we're going to add up all of the numbers in red and divide it by 10 because there's 10 values. So if we do 1.64 plus 1.24 plus 1.24, etc., and add up all of those red numbers and divide by 10, it'll tell us that our MAD, our mean absolute deviation, is 1.496. So this is a very small mean absolute deviation. What this means is on average, each of these cities' populations is 1.496 from the average of the cities. So they're not varying much until you look at it from the perspective that we're talking about 1.496 million. So the measure tells us how much on average the number of coins in a stack differ from the mean. That's what the mean absolute deviation does. It tells us how much it differs from the mean. So if the MAD is smaller, it tells us that the values in the set are consistent. Or more consistent. So if the MAD is larger, we know that at least some of the values are more spread out or less consistent. So moving to another couple of examples. For example 2, it says the table shows the number of calories in several sandwiches at 2 restaurants. And we're going to find the MAD for each set of data. So for Susan's Sub Shop, we're going to create a table. So our X values for Susan's, and they don't have to be in order to do this. Sometimes it's nice to see the progression. So I'm not going to put them in order for this one just to show you. So we have 490 is your first X value, 380, 270, 430, 510, and 410. So when you find the mean of this data, you're going to get a mean of 415. So on average, the sandwiches have 415 calories. So to find the mean absolute deviation, the next step is that we're going to subtract the mean from each of these X values. And I'm going to go ahead and write it as positive because we're looking for the mean absolute deviation. So when you do 490 minus 415, you get 75. 380 minus 415, make it positive because we're looking for the distance to 0. 270 minus 415 and make it positive. 430 minus 415, make it positive. 510, make it positive. And 410, make the difference positive. So you always want the difference to be positive. So to find the mean absolute deviation, we're looking for the mean of those, which gives us 61.6. So again, you add up all those numbers in blue, divide them by 6 because that's how many numbers there are, and it gives you your mean absolute deviation. And as a refresher, this is your X minus your mean, but it's the absolute value of it. So we always write it positive. So we're going to do one more. We're going to do the picnic basket. So our values are 550, 320, 470, 430, 610, and 290. You have to find the average of those numbers. So the mean for the picnic basket is 98.3. Excuse me, I'm looking at my wrong numbers. The mean of that data set is 445. So again, we're going to subtract that mean from each of our data sets, and whatever answer you get, write it as positive because we're looking for the absolute value of it. So again, this is going to be the absolute value of your X minus your mean. So when we do 550 minus 445, we get 105. 320 minus 445, make it positive, is 125, etc. So to find the mean absolute deviation, you add up all the numbers in blue, divide by 6 because there's 6 of them, and your mean absolute deviation is 98.3, repeating. So what does this tell us? That Susan's Sandwich Shop, the calories in those 6 sandwiches is more consistent. So those calories are more consistent. Most of her sandwiches have similar number of calories as compared to the picnic basket where they're more spread out.